Good morning and welcome to take 2 of my attempt to record this practice SAC walkthrough. So what I've got here is practice SAC for Graphs and Relations module for Unit 4 Further Maths. The owner of a Ford Falcon sedan is considering converting the car to gas. He estimates that it currently costs him $12.50 in petrol costs for every 100 kilometres that he drives. Write an equation for P, which is the cost of dollars for petrol, in terms of K, where K represents 100 kilometers of travel. So for every 100 kilometers, it's $12.50. So the easiest way to represent this equation. So first things first, write an equation for P. So P is what we're looking for, and everything is in terms of K. Well, that's every 100 kilometers, it's $12.50. So that's just going to be 12.50 times K, or you could just write it as 12.5K. So next task is to draw that relationship on the axis, but it's only for the values between 0 and 150. All right, so we don't want to go beyond that. So even though our axis goes all the way to 170, it's specifically asking us to stop at 150. So what we do is we'll get our CAS, and on our CAS under graph section, well, we're just going to put 12.5x in there. X, K interchangeable for the purposes of what our CAS is doing. Now, there's our line. Problem is that if you look at the axes that we've got on the SAC and the axes on the CAS, they are very different. So to help us draw it properly on paper, we want to make sure our CAS looks similar to the paper that we're working with. So for that, we're going to go and fiddle with the zoom. So along our x-axis, along here, it's in blocks of 10. So on our CAS, I'm going to say our x minimum is going to be, we'll say minus 10. We don't want it to be exactly 0 because then it's hard to see the markings. We're going to say the maximum is going to be 170 because, again, we want it to show the sort of range that our actual graph has. And the scale is going to be 10. Don't worry about it, not important. Then we want to go all the way up to 2400, and the scale is going to be 200. Again, don't worry about the dot, let that adjust automatically. Going to hit OK, and then we're going to get this graph that we've got here, which now the axes look very similar to what is actually given to you on the page, and that is something that we can now work with. So on our graph, we can go through and we can plot and find some points. Now remember, to draw a straight line, you only need 2 points and then connect the dots. Now obviously, we're given a point for free because if you haven't driven anywhere, how much does it cost? Well, it also costs you nothing. So therefore 0, 0 is a perfectly valid point on there. Now, looking at my CAS, it's also said that 80 is at 1,000. So we can put there 80 at 1,000. Now, if I move along, everything is like in decimal points. However, if I'm in this stage where I am moving it around, I can, in fact, just start typing a number. And this window pops up. X value. 150 is at 1875. So what we're going to do is we're going to estimate where it is because obviously our markings are only in groups of 200. So halfway between 1800 and 2000 is 1900. And then 3/4 of the way to halfway is going to be our last point there. So that's 150, 1875. So now that I've got those points plotted, we draw a straight line to connect them up. Now, obviously, you guys are going to be using a ruler. I'm going to be using the straight line tool in Microsoft Word. And when I do it properly, I make the line nice and thick and obvious for you, you'll see that it passes through all of my markings. So it passes through that little red dot down the bottom at 0, 0, and there, and all the way up there as well. Makes it nice and good looking. All right. So with that graph done, we also forgot to label it, because it says here, label this line P. So that's what I'm going to do. Okay, label this line P. Going down, the owner researches the cost of a gas conversion and finds out that after government rebates, it will cost him $550 to convert his car. A friend who has already done the conversion gives him advice and says that it's actually the gas cost is only about $6 per 100 kilometers. We now need to create an equation G to represent the cost of traveling on the gas. But we also have to take into account the initial cost of doing the conversion. So, like most linear equations that we're creating, we want to do it in y equals a plus bx form, where a is our constant value and b is our gradient. And obviously, we want to make sure that we are using g and k. So, in this case, this g is y. This 550 is a constant cost. So that's going to become our A. K is going to go where X is. And then that 6 is going to replace the B for us. So the actual equation that we want to write for this is G equals 550 plus 6 times K. So G equals 550 plus 6K. D, add this relationship to the graph above for 0 to 150. Label this line G. All right, so we're going to go back up. So let's go to our CAS. We've already got our CAS set up. Beautiful. Let's keep going. 550 plus 6x. We're going to draw that graph on there as well. And you'll notice that it is slightly higher, but also at a slightly shallower angle, which is what we want. So we're going to add this line. So first things first, let's grab an intercept. Obviously, when you haven't driven anywhere, all you have to worry about is the cost of the conversion. So I'm going to do these dots in green. So halfway between 400 and 600 is 500. Halfway between 500 and 600 is going to be 550. So that's where my first mark is going to be. So that's going to be at 0, 550. And then, using my CAS, I'm going to trace along the red line, and I'm going to go to 150. And that's only going to be 1450. So at 150, we're only going to be at 1450. So that's going to be a quarter of the way between 1400 and 1600. So it's going to be about there. And we're going to make a mark of that point, 150, 1450. Close the bracket. And we now have 2 points that we can use to draw our line. But I think just to make sure that we're getting perfectly accurate, let's use our CAS and we will move along to see if we can find something a little bit more consistent. Or rather than trying to find, like a needle in a haystack, we can press this button here and it brings up a table of values. Now I've got it set up here. Starts at 0, ends at 180. Steps of 10. That means X is 0, 10, 20. And I can go through here and I can find numbers that possibly line up perfectly. Now in this case, not so much. So we'll stick with the two values that we've got, and we are going to draw a line that connects them. Now, because we are doing this on a piece of graph paper, we should be able to note something rather interesting. Now I'm just going to make that line a little bit thicker for you all. There's a crossover point. I wonder if that's going to become useful in a minute. Spoiler alert, yes, it will become interesting. It will become relevant. So we've got our line there. We're going to label it G. So P is this line here. G is the brown line. So how far to the nearest kilometre does the owner need to travel before he is broken even on converting his car to gas? Where has he broken even? So when is the cost of running gas and the cost of running petrol overlap? Where is it exactly the same? Now we can use our CAS for this. So we want to go back to our graph. We want to go analysis, G-solve, intersection, and we get this thing behind me. 4.615385. So I'm going to write this down. I'm going to write this down because just by writing this answer, so that's 4.615385. That is just a number. That number represents something in the context of the question. So just writing that answer isn't enough for full marks. In fact, you'd be lucky to get any because it's wrong. It needs to be converted. Now remember, that value of K is 84.615385. But in the context of the question, 1K pronumeral, is actually equal to 100 kilometers. So what I need to do is I need to convert this K value to an actual kilometer distance measurement. So if 1K is 100 kilometers, 84.615385 is going to be 8,461.5385 kilometers. But I'm not finished yet because the question says to the nearest kilometer. Now, because the decimal points are 0.5 or above, we're going to round everything up to the nearest kilometer. So that is going to therefore be 2 kilometers. So 8,462 kilometers. We are now going to use this question or this answer in the next part. If the owner travels 450 kilometers per week on average, how many days to the nearest day will it take him to break even on the conversion? So, what we need to do is we need to figure out, well, if he travels 450 kilometers a week, how far does he travel a day? Because what we want to do is, that's what the question is asking us for. The question is asking us for a number of days. The current thing that we have is weeks. So let's convert it to days. Then we could use that with our previous answer, the 8,462. and we can go from there. So on our CAS, we're going to go back to the main screen, and we're going to go 450 divided by 7. Our CAS is going to give it to us as a fraction because we're in standard mode. So I'm just going to hit convert to that, and I've got this number here. Now that's telling me that on average this car is traveling 64.28571,429 kilometers a day. Now I'm not going to round that just yet. We round at the very end. So I'm now going to take that I'm now going to go 8462 and divide it by ANS. Now on your keyboard, ANS is found in Math 1, Math 2, and Math 3 in the bottom right corner of the keyboard, next to the EXE button and the copy paste buttons. So I'm now going to type that, and I get this fraction, which I then convert, and I get 131.63111. That is how many days it will take for the owner to break even. But again, the question wants it to the nearest day. So I'm going to take my 831.63111, and I'm just going to round it to 132 days. Next part. Write an equation for the profit made after converting to gas. Now remember, the profit is going to be the difference between two equations. So the converting to gas, what we're going to do is we're going to take the cost of the gas and subtract it from the cost of the petrol. Because what we want to do is we want to find that point where the equations overlap, which we've done previously, the 84.615, that's where it overlaps. But what we want to do is we want to have an equation that says, well, okay, if I've driven 100 kilometers, which one is better value? Is that going to be the gas or the petrol? So we can create an equation by subtracting one of our equations from the other one. So what we're going to do is we're going to go, the profit is going to be equal to the cost of the petrol minus the cost of the gas. So we're going to take equation P that we made earlier and equation G that we made before, and we are going to subtract them. All right, so on our CAS, we can actually go in and we can use our CAS to do this. So we want to go action, transformation, simplify. And then we're going to type in our petrol equation. So that's 12.5x. And then we're going to subtract all of equation G from it. And we get this thing here, which, if we convert to decimal, is that. Now, the way our CAS is written, it is written in y equals mx plus c form. So to get it into a plus bx form, we need to just simply swap the minus 550 and put it in the front. So in this case, on our CAS, we're going to write the answer. So the profit is going to be negative 550 plus 6.5. So that's our profit equation for the conversion. Because until we've hit that break-even point, until we've hit that point where the costs are exactly the same, technically changing over to gasoline is causing us to lose money. Because we had that initial gigantic outlay of money to get the conversion done. So the next part is, what is the profit made when the car has traveled 20,000 kilometers? Now, do not just put 20,000 into our equation. Because remember that K is hundreds of kilometers. And what we're dealing with is 20,000 actual kilometers. So we need to convert that 20,000 into a K value to put into our equation. All right, so what we're going to do is we're going to divide the 20,000 by 100, and we get to 200. We'll then put the 200 into our profit equation. So that 20,000 is going to become 200. So we're going to say K equals 200, and then we're going to put it into there. So I'll take my equation here, drag it down, and then replace the X with 200, and we get the answer 750. Now remember, the CAS does everything in BODMAS, so it will actually do the multiplication first, then do the subtraction. So that answer is going to be, what profit is there? Well, it's $750.